All right, we are up to lesson 6. Once again, no new lesson notes, so we're going to go ahead and get right into the examples. So here is a graph representing an exponential growth function per year. Find the growth factor per 2 years. So to find the growth factor, divide any y value by its previous value. So divide any y value by its previous value. So in this case, I'm going to take 9 and divide it by 4. Okay. 9 divided by 4. Use a calculator if you need to. So 9 divided by 4 is 2.25. So my growth factor per 2 years is 2.25. Why is it the growth factor per 2 years? Because notice the x value goes from 0 to 2. Okay. Number 2, write the equation of the function per 2 years. So the equation of the function, so I'm going to use this formula again. What is my initial value? My initial value looks like it's 4. Okay, my initial value is 4. My growth factor, we said, was 2.25 to the power of x. So 4 times 2.25 to the power of x, but x in this case is the number of 2-year time periods. Okay? So x equals 1 really means 2 years. X equals 2 really means 4 years, so on and so forth. Number 3, write an expression for the value of the function after 1 year. So I can't plug in x equals 1 because x equals 1 really means 2 years. I have to actually plug in x equals a half because 1 year is really a half of a 2-year time period, right? 1 year is half of a 2-year time period. So I'm going to plug in a half for x. So 4 times 2.25 to the power of 1/2. And that's all we had to do for number 3. Number 4, we're going to do the same thing, except now we want to write an expression for the value of the function after 5 years. So after 5 years, again, if I plug in x equals 5, that really means 10 years. Okay? So I have to do the same thing I did in number 3. I have to take the number of years and divide it by 2. So 5 divided by 2 is 2.5. So 5 years is really 2.5 2-year time periods. So I'm going to plug in 2.5 for x this time. So this would be 4 times 2.25 to the power of 2.5. Okay, so that's your answer to number 4. Number 5, write an equation for the value of the function per year. So the key is we have to take the number of years and divide it by 2, since my original function was per 2 years. So how is that going to look here? It's going to be 4 times 2.25, and I'm going to use t for years. So 4 times 2.25 to the power of t over 2. Right? If I plugged in t equals 1, I would get a half. If I plugged in t equals 5, I would get 2.5. So t in this case is now number of years. So that is my equation for the value of the function per year, and that is it for this lesson.